The next section we're going to cover is on rational exponents. They follow the same rules of exponents that we've already had, but adds a little twist to it. And before we can talk about rational exponents, first thing we need to do is remind you what a rational number is. And a rational number is any number that can be written as a fraction where both a and b are integers and b is not equal to 0. Okay? And in this case, what we're going to do is we're going to figure out how this rational exponent comes into play. Okay? So let's say x is equal to 4 squared. Okay? What I want to do is, what do I need to raise this 2 by in order to make it disappear? Okay? So if we remember our power to a power property, x to the m raised to the n, we end up multiplying the two exponents together. So what I want to do is I want to figure out what do I have to do to undo this squaring operation. Okay? Most of you should understand that to undo a squaring operation, I would take the square root of both sides, and this would say that the square root of x would just equal 4. Okay, we're going to do it a different way. We're going to write x equals 4 squared again. And we're going to think, what number do I have to multiply to 2 to get to 1 to get back to this 4? Well, and that would be 1/2. Because 2 times 1/2 is 1. If I raise this side to the 1/2 power, I have to raise that side to the 1/2 power. So I get x to the 1/2 is equal to 4. So what I just showed you is that the square root and raising something to the 1/2 power is the exact same operation. So using this fact, we're going to come up with what does a rational exponent really mean? And what the rational exponent really means, if I have x to the m over n, the top number means a power, and the bottom number means a root. For example, if I have 4 to the 3/2, this says to take there's two different ways I can write this. This says to take the square root of 4 and then raise it to the 3rd power. Alternatively, I can raise 4 to the 3rd power and then take the square root. If you are dealing with rational exponents, my recommendation is that you always take the root first and then raise it to a power. Okay, 4 cubed is 64, and then take the square root, and I get 8. Okay, that's fairly straightforward. But here, the square root of 4 is 2, and then 2 cubed is 8. It's a lot easier to raise smaller numbers to powers than it is to take roots of bigger numbers. So my recommendation is you always take the root first, and then raise it to a power. So what I'm going to do is I'm going to use this property right here to do 8 examples, and then you will have a half sheet of practice problems to do after you watch this video, and then tomorrow in class you'll have about a dozen or so problems to do practicing using rational exponents. Okay, 16 to the 1/2 power is the same thing as the square root of 16, which is memorized to be 4. 25 to the negative 1/2 power is 1 over 25 to the 1/2 power. Negative exponents say to flip the number over, change the sign of the exponent, which is 1 over the square root of 25, which is 1 over 5. Okay, 9 to the 5/2 power. We're going to take the root first, and then once we get the root, we are going to raise it to a power. So this would be the square root of 9 raised to the 5th power. The square root of 9 is 3. So we have 3 to the 5th. And this was one of those I asked you to memorize. If you don't have it memorized, use your fingers, starting with 2, then multiply by 2. So 2, 4, 8, 16, 32. 3 to the 5th is 32. Next example is 4 to the negative 3 halves. That would be 1 over 4 to the positive 3 halves. This says take the square root of 4 and then cube it. I've already got this work here. Square root of 4 is 2, and 2 cubed is 8. So this would be 1 over 8. 8 to the negative 2/3 is 1 over 8 to the positive 2/3. This says to take the cube root of 8 and then square it. What number times itself 3 times is 8? And that would be 2. And then 2 squared is 4. I'm going to pause the video and change out the microphone. So our next example is 64 to the 4/3. So we take the root first, the cube root of 64, and we're going to raise that to the 4th power. The cube root of 64 is 4. So that gives me 4 to the 4th. And this is one of those I did ask you to memorize. Okay, 4 to the 4th is 256. Another way you could think about 4 to the 4th is this is 4 squared squared, which is 16 squared. And again, it shows you it's one of our memorized perfect squares. Now let's start adding other properties in here. When I have two things to the same base raised to exponents, I add the exponents. So if I have 5 halves minus 1 half, that gives me 4 halves. 4 halves is the same thing as 2. So my answer would be 12 squared, which is 144. Okay? For the next one, when you multiply exponents, you add the exponents. When you divide things with the same base with exponents, you subtract the exponents. And this is one of the reasons why they taught you fractions, is so you can deal with these exponent problems. So in order to add exponents, this is a 1, but I need to write 1 with the denominator of 3, so I'm going to write it as 3/3. And then let's just write this out. It would be 6 to the 4/3 plus 3/3 minus 1/3. 4 plus 3 is 7, minus 1 is 6. So that gives me 6 to the 6/3, which is 6 squared, which is 36. Okay. Notice I did not use a calculator on any of these problems. Okay? Your calculator does not have a fractional exponent button. Okay? If you want to check your work with a calculator, what you're going to do is you're going to raise whatever number. So let's go to this one, 4 to the 3 halves. You would type in 4, the caret symbol, open parentheses, then 3 divided by 2. So if you want to use a calculator to check your work, this is how you would enter the rational exponent into your calculator. Okay, I'm going to warn you, though, that there are going to be times that this is going to give you a decimal answer. And when we get to Algebra II, we're going to want exact answers. So you're going to have to learn how to manipulate these exponents to come up with exact answers, where sometimes you're still going to have a root symbol as part of your answer. So that's it for rational exponents. You're going to have a half sheet that you're going to do tonight after you watch the video, and then tomorrow you're going to have about a dozen problems you'll do in class.